The next part of the lesson is still working with these quadratic graphs. We want to identify the maximum minimums, which we already know how to do that. We'll simply look at the value of a and see if it's positive or negative. If a is greater than 0, it's positive, and it will have to be a smiling curve, which means we'll have a minimum. If a is less than 0, then we know that we're going to have a maximum point because our graph is going to be frowning from that point. So a is going to determine whether we have a maximum or minimum, and all we got to do is look at whether it's positive or negative value of a. That part is going to be relatively easy, finding the maximum min, because we did it in the previous problem. Where we'll probably have to spend more time and more effort thinking about is how do we define the domain and range, because in this question they're going to ask us to define what's your set of inputs called your domains, and what are all the possible output values, which are called the ranges. The nice thing about that is that the domain of the quadratic function is always a set of all real numbers. So in every single quadratic equation that we deal with, the domain will be, for sure, the set of all real numbers. So I'm going to just write that in symbols here. Domain, I'm representing that, will be the set of every real number that we can do, which means the inputs are endless and infinite. You can put in whatever you'd like for the input values of x. Now the range, on the other hand, will have to be determined by whether it's a maximum or minimum. So we're going to be describing what the range, and the range is going to be your potential outputs. Our potential outputs differ based on whether it's a max or minimum. For instance, if we have a minimum point, then we know the lowest y value. So every single y value from there must be greater than or equal to it. So in essence, our range is going to have to be greater than or equal to whatever that value of y is. If we had a frowning curve where we had a maximum point, then we know that where our top of the y value is. So we know that all of our values for the range must be less than or equal to y, and that's the idea that we're going to be putting in here. Our y values will be either greater than or equal to, or less than or equal to the value of y in our max or minimum point, or the vertex. So that's probably where we'll spend most of our time trying to think about the actual domain and range, and that's going to become a bigger and bigger issue as we go through more and more lessons throughout the year. So their first question is determine whether the function has a maximum or a minimum value. Well, I know that the value of a is my sole determiner on whether or not it's going to be a maximum or minimum, and because a is equal to a negative 3, that means that it's negative and it's going to be a frowning curve. And every time we have a frowning curve, then we are going to have a maximum point. So it's fairly easy by inspection to determine you have a maximum. The second part, finding the maximum or minimum value of the function, we did that earlier in our previous lesson. So what we're going to do to find the maximum or minimum, we can find the location of the x value of the maximum or minimum by taking the calculation negative b over 2a, which means we have to put in a negative times b, and b is a 12, divided by the value of 2 times a, which is 2 times a negative 3. We run our calculations, it's a negative 12 all over a negative 6, which means the x value of our maximum min is 2. So now that we know what the x value of our vertex is, we can go and find the y value by plugging it back in to our equation. So we're going to do the calculation over here. I'm going to put y equals, I'm replacing f and x with y. There's no big deal about doing that. They represent the same thing. We're going to put in a 2. We're going to square it. We're going to add to it 12 times 2, n plus 11. The result of this is going to be our y value for our vertex, so we will know where it's located. So order of operations forces me to square the 2 first, and 2 squared is 4, and 4 times a negative 3 is a negative 12. Then we're going to have 2 times 12, which is 24, plus 11. Well, these two combined will give me a 12, and it'll be a 12 plus 11, and 12 plus 11 is going to give us a 23. So at 223, we have now identified what appears to be, and since it was a maximum, this is going to be our maximum value. So we have a curve that's coming up, coming down, and the maximum point is 23. I have one more follow-up question. It says, state the domain and the range. Well, because it's a quadratic equation, the domain is simple. The domain in every quadratic is the set of all real numbers, which means we can use any number that we want on the number line. The range, on the other hand, has a bit of a restriction. We don't get to use every real number off the number line. Since it's got a maximum of 23, we know that our y value, so I want the set of all y values that are less than or equal to 23. For my graph, and knowing that I have a maximum point, I know it's never going to go above that. So that's how we're going to determine our domain and range in a quadratic function.